Hi, I'm an old guy and I do maths. And it's been a while since I did any long division of polynomials for this channel. And so I thought I'd um, put out another video on this. And I chose a particularly awkward one to do. When I say chose, I made this up. I think that this is going to have a remainder. I do not know because I haven't done it. You're going to see me do this as I talk my way through it. So we have 3x cubed minus 5x squared plus 6x minus 3 divided by 2x plus 1. And this 2x minus 1, this 2x minus 1, the 2 in particular, this coefficient, is problematical, as you can see. We're going to have to find some way of getting this into that. Okay, so I'm going to need to deal with a lot of fractions, and I'm going to just keep a pad to my side for working, and I'll show you my working as I go, and I'll talk my way through this. This will take a little bit of time. Now, here's the setup. I'm using long division, as the title suggests, and how I do this is I ask myself a series of questions, and as I answer them, I get my solutions. So my first question is, what do I have to do to x to get x cubed? And the answer is that I multiply it by x squared. My next question is, what do I have to do to 2 to get 3? And the answer is multiply it by something. And here's how I can work this out in my head, probably you can too. But here's the method. 2 times a equals 3. This is how you solve these problems for much more difficult numbers. So a is equal to 3 over 2. There we are. So first part of this problem solved. I've got to multiply 2x minus 1 by 3 over 2x squared. And when I do that, I get 3x cubed minus 3 over 2x squared. That's my first step. And I subtract that. Now, that's going to leave me with nothing. The interesting piece of work is here. And so what is this going to leave me with? Well, it's negative 5 plus 3.5. Sorry, not 3.5, 3 over 2, 1.5. Let me just say that again and write it out here so that you can see it. So, negative 5, what did I say? Plus 3 over 2. So that is negative 5 plus 1.5, negative 5 plus 1.5. This all makes it simpler, which gives me negative 3.5, which is equal to negative 7 over 2. Okay, so down here I'm going to have negative 7 over 2x squared. That is the result of taking this this expression here and subtracting this expression here from it, which is effectively the same as adding. Okay, now I bring down the 6x, and my next question is, what am I going to have to do to x to get x squared? Well, I'm going to multiply it by x. Next, and slightly thornier problem, is what do I have to do to 2 to get negative 7 over 2? And this is where the method I outlined earlier comes in handy. So 2 times a equals negative 7 over 2. There's my setup. Now, what I'm going to do is I'm going to solve for a, and that's going to give me the pronumeral that I need for x here. Okay, so a is equal to negative 7 over 2 divided by 2. Well, very simply, if you want to divide a fraction by 2, you double the denominator. So the answer is negative 7 over 4. But I'll go through the motions. Negative 7 over 2 times 1 over 2. So that's changing this and flipping this. So this is 2 over 1, so I make it 1 over 2. And that gives me negative 7 over 4. Okay, so this number up here is 7 over 4. Is that what I wanted? I wanted negative 7 over 4. So there, a negative. Right. What is the result of that? Well, it gives me negative 7 over 2x squared, which will effectively deal with this, plus negative 1 times negative 7 over 4, x will be plus 7 on 4x. And I subtract that. Okay, so that's going to disappear, and I've got 6x minus 7 on 4x. Well, 6x is 24x on 4. 6 fours are 24, divided by 4 gives me that. Excuse me. Minus 7 on 4x, which leaves me with 17 on 4x. So this number down here is 17 on 4x, and I'll bring down the 3. Okay, next question. What do I have to do to x to get x? Nothing. So really, I'm really just dealing with numerals now. Okay, fresh page. So I want 2 times a to equal 17 on 4. That's what I want to have happen. So a is going to equal 17 on 4 divided by 2. We've been through this before. It's 17 on 8. Okay. Now, I hope that is clear. So I want a positive 17 on 4, so that is going to be positive 17 on 8. When I multiply this expression by this, I get 17 on 4x minus 17 on 8. Okay, so subtract. This disappears, and I'm left with negative 3 plus 17 on 8. Now, negative 3 is negative 24 on 8. 8 3s are 24. And to that, I am adding 17 on 8. And that is going to leave me with negative 7 on 8. So that plus 17 on 8 is going to leave me with negative 7 on 8. Okay, I hope this is continuing to make sense. There are a lot of fractions in here, and there's a lot of processing to do. So what does that leave me with? Well, it tells me that the answer to my question is 3 on 2x squared minus 7 on 4x, which I'm just writing in here, but I'll reference the original up here, plus 17 on 8 minus 7 on 8 divided by 2x minus 1. Now, so as you saw up the top of this page, 3 on 2x squared minus 7 on 4x plus 17 on 8, and I had this remainder. This is the remainder. And how we deal with remainders is we either note them like this, or we divide them by this. And that's what I've done here. Now, I'm able to tidy this up. So just let me go to work on that. So I have negative 7 on 8 divided by 2x minus 1, which is, I'll do it over here, negative 7 on 8 divided by 2x minus 1 over 1. So that is negative 7 on 8 times 1 over 2x minus 1, which is negative 7 over 8 into 2x minus 1. I hope that that makes sense. So, final answer, 3 on 2x squared minus 7 on 4x plus 17 on 8 minus 7 on 8 into 2x minus 1. So, long story short, if you want to divide 3x cubed minus 5x squared plus 6x minus 3 by 2x minus 1, this is one way to do it. And what you see down here is your answer. Thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you again later. Bye-bye.